All right, welcome back everybody. We're going to start up chapter 11 today, and chapter 11 deals with three-dimensional shapes. Okay, so 3D figures. And with 3D shapes, there's going to be two things we do. We're going to find surface area and volume of a whole bunch of different types of 3D shapes. Okay, in 11.2, what we're going to focus on is finding the surface areas of prisms and cylinders. Okay, so surface areas of prisms and cylinders. Let's get rolling with that. All right, let's start off by talking about a prism. I'm going to say a prism is a polyhedron. Polyhedron just means, we'll say 3D shape. Okay, so a polyhedron with two congruent parallel faces called the bases, and the other faces are the lateral faces. Okay, so with a prism we have on opposite side of the prisms two congruent and parallel bases. So I can say top and bottom of this rectangular prism are the bases. And then the shapes that make up between the bases, we'll say are the lateral faces. Okay, other thing we have, we're going to say a height is the perpendicular segment that joins the bases. And then for a prism, we're going to look at finding the lateral area and the surface area. I'm going to say the lateral area of the prism is the sum of the area of the lateral faces. Okay, so those faces in between my bases. And then the surface area is the sum of the lateral area and the two bases. Okay, so in other words, add all this stuff together, add all these pieces that make up this prism together, and that's going to give you your surface area. All right, so let's start off by finding the surface area of a prism. And we're going to start by doing this the hard way using a net. In a few minutes, we'll make life easier for you by giving you an equation. But I want to start with the hard way just so we can really visualize what's happening here when we're talking about surface area. Okay, now if I want to find the surface area of this, let's say it looks like a box, we'll call it a box here. Basically what I'm doing is I'm figuring out what the area of all the shapes that make up its outside are. Okay, again, if I think of it as a box and I unfolded it and laid it flat, the surface area is going to be the area of that flat shape made when I unfold this, the area of that net. Okay, so let's go ahead and make a net. I'm going to start with this front face of the box. So let's draw that out here. So I have a rectangle that is 5 by 4. Okay, next to that, on the right side is going to be this edge, or this face. Which is going to have dimensions of 3 by 5. Okay, because we're going to have the same 5 here. Okay, we also have the top side we see, which would be this face right here, which should have dimensions of 4 by, this side's got to be matching here, so that'd be a 3 again. And then we'll have a bunch of sides that I can't see in my picture here. I'd have the left side of the box, which would be another 5 by 3. Okay, we'd have the back of the box, which would match the front of the box. So another 5 by 4. And then we'd also have the bottom side, which would be congruent to the top side. Another 4 by 3. Okay, so that's my box unfolded. And once I have it all unfolded and broken down to rectangles, it's pretty easy to figure out what the area of each of those rectangles are. Okay, just multiplying together. 5 times 4 would be a 20. Okay, 5 times 3 would be a 15. Kind of underline them just so I don't lose them. 5 times 4 would be a 20 again. Okay, 4 times 3 is a 12. 4 times 3 is a 12. 3 times 5 is 15. Okay, so my surface area, we'll say SA for short, is just equal to 20 plus 15 plus 20 plus 15 plus 12 plus 12. All right, so let's see here, 40, 70, 80, 90, we'll say 94, we'll say centimeters squared, since we're talking two-dimensional area. Okay, that was kind of a pain. It's tricky drawing nets, and I especially don't want to be drawing nets for some of these uglier shapes we're going to get into in a few minutes. Scroll back here. So that's why I want to come up with a formula here. Let's take a look at where that's coming from. All right, so what I have for here is a little virtual manipulative. Okay, I have a 3D prism that you can grab and drag around. Okay, there's a link for this on my Moodle page. It's fun, but we'll stop that. And with this slider here, what I can do is I can unfold it into that net and really visualize and see how the unfolded shape relates to that actual prism. Okay, so I can fold and unfold. And let's kind of take a look at a shortcut we can come up with. Notice that when I unfold this and I think of it in terms of bases on the top and bottom, and then lateral area, which is these four sides around the middle, what I end up with unfolded is really just three shapes. Okay, two rectangles for my bases, and then a larger rectangle for my lateral area. Okay, what are the dimensions of these rectangles? Well, the base is just the area of the base, length times width. And then that larger rectangle, the trick what I can do is I can just multiply the height by this longer dimension here. What is this longer dimension here? Watch this red line as it folds. Well, it is the perimeter of my base. All right, so that's where my formula for surface area of a prism is going to be coming from. Basically what we just did there. Okay, we have formulas for the lateral area, we'll say LA, and surface area, which we'll say is SA. The lateral area, I'm going to say, is the product of the perimeter of the base and the height of the prism. We'll just write that as LA equals P times H. And then surface area is the sum of the lateral area and the area of the two bases. So surface area equals lateral area plus 2B. Okay, let's go ahead and use that in a problem here. All right, and to show you how to use that formula, I actually want to do the problem we just did a minute ago. Okay, where I have actually the same net here. This one looks a little nicer than the one I drew. Okay, for us to do. Because I really want you to see how that formula relates to the actual shape and the idea of a net. Okay, so a formula said that lateral area, LA, is equal to P times H. So as in a perimeter of the base times the height of the prism. Now with a rectangular prism, I could use really any sides I want as the bases. I could use top and bottom, or the left and right sides, or the front and back. Okay, let's think of my top and bottom as the bases for this one, just to kind of make it look like the visual we showed you a minute ago. Okay, so perimeter of the base is going to be the distance around the outside of my base. So we could say 4 plus 3 plus 4 plus 3. Okay, and then times H, the height of the prism, the distance between the bases, which would be this length right here, so times 5. And what that's going to do in all in one step is take care of this lateral area, this entire rectangle. Okay, 4 plus 3 plus 4 plus 3 from the perimeter of the base times the 5. That'll knock this whole area out in one step for me. So what do we got here? 14 times 5, 70. Okay, then the surface area we said is equal to the lateral area plus 2b. In other words, the lateral area we just found, 70, plus 2 times, and we need the 2 because there's two bases, the area of the base, which would be just 4 times 3. And again, what that's going to do is knock off these bases, these other rectangles we have. Okay, so 70 plus 24, that gives us 94 centimeters squared. I think that's the same thing we got a few minutes ago. Hopefully that's the same thing we got a few minutes ago. Okay, but what I'd like you to see here is that it's obviously easier when we use that equation rather than drawing on a net every single time. All right, let's do something really ugly next. Okay, so I definitely don't want to have to try to draw a net of a trapezoidal prism like this one here. And I'd say trapezoidal because the bases, the two congruent sides, parallel sides, are trapezoids. So let's go ahead and apply that formula to it. Same formula no matter you're talking rectangular prism, trapezoidal prism. I think we'll do a triangular prism in a minute. We're going to do cylinders, which are really like circular prisms. Okay, so we said that the lateral area is equal to P times H. So perimeter of the base times height of the prism. Now, like I said, with a trapezoidal prism, I've got to use these trapezoids as my bases. Okay, they are the only two sides that are both parallel and congruent to each other. So the perimeter of my base will just be these four sides added together. We could say 4 plus 2.8 plus 4 plus, we use that 8.1. So, and then we're going to multiply that by the height of the prism. That's the distance between my bases. Okay, this 3 here is the height of the trapezoid. We'll get to that in a minute here. Okay, but if my bases are at the front and the back, that means the height's going to be the distance between them. So we'll say times 12. Okay, when I multiply that through, I get a 120. Oops. I'll do that. 26.8. We'll squeeze it in there. And again, what that just took care of was all four of these lateral faces between the bases at one time. And then from there, we'll go surface area equals the lateral area we found plus 2b. Okay, so in other words, the lateral area, that 226.8, okay, plus 2 because there's two bases. Okay, and then the formula we use for the base is going to be the area formula for whatever type of base you're looking at. In this case, it's a trapezoid, so we've got to use our half times height, which is 3 here, distance from base of the trapezoid to base of the trapezoid. Okay, and then times base 1 plus base 2. And the bases of my trapezoid would be the 2.8 and the 8.1. Okay, and when I'm just plugging this all straight into my calculator. When I multiply that through and add it to the 226.8, I end up with a 259.5, and we don't have units. Anyways, that'd be squared here. All right, so on to problem C, and this is going to be the other tricky one for the day. Just because of a little extra work we're going to have to do at the beginning. Otherwise, it won't be too bad. So we'll see what's the surface area of the prism. And this time I'm going to say I have a triangular prism. Okay, triangular prism because my two bases on top and bottom are both triangles. And again, I have to use these as the bases because the top and bottom are the only two sides that are both parallel and congruent. And where the extra work's going to come into play is notice with this base on the bottom, I know two of the sides, but I don't know this third one here. We'll call that X. Okay, now if I want to find the perimeter of my base, I need to know all the sides. So first thing I need to do here is solve for X. Okay, since this is a right triangle, I can do good old a squared plus b squared equals c squared, Pythagorean theorem. And let's see here, the x is my hypotenuse. So we'll say x squared on the right, and then the 3 and 3 will be my a and b. All right, so 3 squared is 9, 9 plus 9 is 18, so I have 18 is equal to x squared. And if I take a square root on both sides, that's going to leave me with x equals square root of 18, we'll say is 4.2. All right, so that missing side we were looking for is a 4.2. Okay, from here, this problem is really the same thing we've done a couple of times now. To find the surface area, we'll start by finding the lateral area. We said that's equal to P, the perimeter of the base, times H, the height of the prism. Okay, perimeter of the base will be the 3 plus 4.2 we just found. And then times H, the height of the prism, that's my distance between my bases. So distance from top to bottom In this case, it's a 10. And when I multiply all that through the calculator, I end up with a 102. Okay, so there's my lateral area. There's the area of the three rectangles that make up the sides between the bases. And then from there we can find the surface area. We said surface area is lateral area plus 2b. Right, so lateral area, the 102 we just found. Okay, plus 2 times b, the area of the base. Well, what kind of base do we have? This time it's a triangle. I know area of a triangle is half times base times height. So we'll say half times base, and we can use the 3 as the base of the triangle. Okay, times the height we can say is the other 3, and I can use 3 and 3 because these are at a right angle. And I'm just again plugging this straight in my calculator. I end up with a 111. So we could say 111 inches squared. All right, now other thing we're going to look at today is finding surface areas of cylinders. Okay, so we've already looked at prisms, and when I say prism, there's really a lot of shapes we're talking about. We could say rectangular prism, we could say triangular, trapezoidal, it could be an octagonal, pentagonal. Okay, I'm going to say though that a cylinder really isn't much different. The way you can think of a cylinder is as a prism with circular bases. Okay, so a prism where the bases, instead of being rectangles or triangles, are just circles. Okay, formally, we're going to find it as a solid that has two congruent parallel bases that's areas or circles. I should fix that typo there. And the height is the distance between the bases. And then to visualize the formula for this, I've got another manipulative for you. So there is a cylinder. And when I unfold this, let's take a look at what happens. I'm left with three shapes once again. A rectangle making up the lateral area. Now, what are the dimensions of this rectangle? Okay, well, one dimension would be the height. The other dimension here is going to be, again, the perimeter of my base. When I fold that together, look at those red lines come together. Okay, that top edge of that rectangle is going to be equal to the perimeter of my base. In other words, the circumference of this circle. So that's where the 2 pi r times h is coming from. Circumference of a circle, okay, times the height of the prism, or the cylinder. And then we also have the two circles. Okay, so we could say LA plus 2b will give us the surface area. All right, and those are our formulas. 2 times pi times r times h, so circumference times height for the lateral area. Or pi times d is another way we get circumference times the height. And then the surface area would just be LA plus 2b. I suppose for the b, we could say pi r squared here for the area of a circle. All right, so let's go ahead and apply that formula to these two cylinders. Okay, we want the surface area, so I'm going to start off with the lateral area. And I like to just write out the same as p times h, like we had with the prism. Okay, what is the perimeter? Well, that's the circumference of this circular base here. And I know the circumference of a circle is 2 times pi times the radius, so times 4. Okay, and then times the height of the cylinder, just like height of a prism. That's going to be distance between my bases, times a 6. All right, and to make calculations easier here, I'm going to leave things in terms of pi. So I'm going to go 2 times 4 times 6, all right, which is going to give me a 48. I will just say 48 pi. And then for the surface area, that's going to be equal to lateral area plus 2b. So in other words, the 48 pi plus 2 times area of that circle. I know area of a circle is pi times radius squared, so we'll just say pi times 4 squared. All right, as I put these parts together, I'd have the 48 pi plus a 32 pi by going 2 times 4 squared, or 2 times 16. And then adding that all up, that'll just leave us with an 80 pi, and I'll say inches squared. Okay, Math Excel might ask you to round one like this, but I believe most of them are just going to say leave in terms of pi. It's going to give us a cleaner, nicer looking answer. Okay, part B is the same idea. Why don't you take a minute, pause the video, work through part B, give that one a shot, and then hit play to check your answer. All right, so hopefully you'll work through this one. We're going to run through it quick. I'm going to hide my face just so I got more room here. All right, so lateral area is the perimeter of the base times the height. Okay, so that's going to be a 2 times pi times 7 to find the perimeter of the circular base, aka the circumference. Okay, times the height, which would be distance from base to base, 22. And again, leaving that in terms of pi, 2 times 7 times 22 is going to give me 308 pi. Okay, then the surface area is the lateral area plus 2b. So as in lateral area 308 pi we just found, plus 2 times area of my circle, pi times radius squared, so pi times 7 squared. So we'll have our 308 pi plus 2 times 7 squared. That'll give me a 98 pi. Add those two parts together, we get a 406 pi, and we can say meters squared. All right, and the last thing we're going to do is apply our different formulas here to a couple of real-world situations. Okay, now the shapes we're talking about in this chapter show up a lot in the real world. But to actually solve real problems, in some cases we're going to have to adjust our formulas to make them fit the real world. So let's take a look at what I mean. Okay, problem 4 says an aquarium is being made with the dimensions shown below. The entire aquarium will be made of glass with the top left open. How much glass is needed to complete the aquarium? Okay, so in other words, find the surface area of this prism, except we're not going to count the top. We're going to leave that open, which makes sense if we want to put fish or whatever, I suppose it's a huge one, sharks or whatever into it. We got to leave it open so we actually put them into it. All right, like I said, we're going to have to adjust our formulas. And basically the way I'm going to do that here is I'm going to say that my lateral area is still equal to P times H. But then my surface area, what I'm going to do is I'm going to say it's equal to the lateral area plus a single base instead of 2b. And that way, if I think of the bottom and top as my bases, I'm just going to add one of those in and skip the top one because, again, we're leaving that top open. Okay, so there's an example how we can adjust these equations. Okay, filling things in there. If the bottom and top are my bases, perimeter of the base would be the 17.2 plus 3 plus 17.2 plus 3. Okay, times height of the prism. That'd be this 5.5. And when I multiply all that through, I end up with a 222.2. Okay, and then surface area will be the lateral area, the 222.2, plus single base in this case, because we're leaving the top open. So in other words, plus we could say 17.2 times 3. That'll give me the area of the bottom part. And when I add it all up, I end up with a 273.8. We can say meters squared. All right, there you go. That's it for 11.2. And honestly, this is probably the toughest section of this chapter just because there's a lot going on with it. So go to town on it, give it a shot, do your best, stick with the homework. And the big thing is if you're getting stuck, if you need some help, make sure you're reaching out, make sure you're asking for that help.